Hello all, I am Mukunthan from University of Surrey. I am here to present our paper, Backward Feature Elimination for Accurate Pathogen Recognition Using Portable Electronic Nose. The authors of these papers are Mukunthan, Tharmakulasingam, Cihan, Topal, Anil, Fernando, and Roberto Ragione from University of Surrey, United Kingdom. This is my outline of my presentation. First, what is e-nose? Electronic nose is known as e-nose. E-nose is used to mimic the olfactory system and biological nose. And e-nose generates electrical signals in response to the volatile components of gases. The volatile components of the gases are the basic parts of the odors. And in normal biological nose, we have three components: receptors, olfactory bulb, and neurons. Similar to that one, electronic nose has sensors array and signal processing and pattern recognition units. If we consider in system-wise, electronic noses include three major parts: delivery system, detection system, and computing system. The delivery system is used to direct the VOC to the detection system, and the detection system consists of arrays of sensors which can sense the VOCs. And the computer system makes decisions using those VOCs, applying feature selection, pattern recognition, and classification algorithms. Normally, the delivery system and detection systems are attached with e-nose, and the computing systems in a separate external machines, and the e-noses are connected using USB connections. Okay, the application of e-nose consists of medical diagnosis and health monitoring, environmental monitoring such as identifying gases, application in food industry such as identifying fruit ripenesses. In this paper, we mainly focus on medical diagnosis and health monitoring applications. The timely identification of pathogen is vital to control the diseases. VOCs are being used to identify those pathogens. So, e-nose are widely used for the identification of VOCs as a non-invasive tool. There are few studies done using e-noses as non-invasive tools. These are few examples: electronic noses for automated identification of volatile chemicals for medical applications, classification of human pathogen bacteria as early screening using e-nose and principal component analysis are few of them. Then why we need machine learning? Because the gases density varies and the sensitivity of sensors varies. So there's no one-to-one mapping to VOC set to pathogen to classify pathogen using VOCs. So the VOC machine learning approaches are used to map VOC set to the pathogens. There are a few studies done on that one. Ensemble-based artificial neural network and SVM methods were applied to VOCs collected from e-noses to predict ventilator-associated pneumonia diseases. And another study, an electronic nose system working based on neural network was designed to identify pathogens. Based on this study, we identified that the identification of VOC signatures associated with microbial pathogens using e-nose is currently inefficient for the timely identification of pathogens, because only few studies done to map VOC set to pathogens, only few studies done to identify significant VOCs from those VOCs, and no studies done to optimize the sensors array in e-nose. And the portability of e-nose is also limited due to the fact the computational complexity of classification is high, and connection with external machine is done using USB connections. So we propose a system which has the same delivery system, but the detection system has configurable sensors array, and the computing system has two parts. One is inbuilt microprocessor or mini computer with the e-nose and external machines. And the inbuilt mini computer and external machines will be communicated via Wi-Fi or Bluetooth connections. In the external machines, the training phases of the machine learning tasks will be done, And those models will be updated to the in-bit mini computers. And so this has the three main parts: designing of those proposed design, and communications between mini computer or the Raspberry Pi or microprocessor to the external machines, and applying machine learning for that ENOS.